Hi, I'm Pat Kelly. Okay, and in this problem, we're asked to find the general solution to this first-order linear differential equation. Okay, so this is going to take a little bit of work. So what I'm going to do is lay out a little bit of a roadmap for us to follow. And what this will end up being are the steps that I would typically think through when I'm doing one of these problems. And when we get to the end, we'll have our answer. Because the first thing I would want to be looking for is whether or not the original equation is in standard form. If it's not, I'd have to get it into standard form. So I'm asking myself if that's in standard form. Of course, you'd have to remember what standard form looks like. Standard form would be y prime plus p of x, y equals q of x. And really, it just comes down to two things. One is that y prime is all alone. There's nothing being multiplied by it. And two, on the right-hand side can be something, but it can't have any kind of y's in it. So if I look up at my equation, I do have that y prime all alone. And on the right-hand side, I have 10x. There are no y's. So this is actually done. That leads me to my second step, where I want to find p of x and q of x. P of x and q of x you can see in the standard form. That comes from the original equation. Then q of x is just whatever's over here to the right of the equal sign. And p of x, the standard form, that's just whatever's being multiplied by the y. So in this step, we're really just doing an identification step. We're trying to get a handle on what p of x is. That's 2x for me in this problem. And we're also trying to get a handle on what q of x equals. And that's the 10x for me in this problem. So in that second bullet, we're just trying to get these two items lined up, because you're going to see that they're ingredients for the recipes that are about to come at us. That gets to me my third bullet. Third thing I need to do is find mu of x. Mu of x, what's called our integrating factor, that comes from a formula that you should know. Mu of x equals e raised to the p of x, the integral of p of x dx power. So we did this work just even with identifying, because that p of x is right here in this formula. So now I can go ahead and evaluate what this mu of x is for me in this problem. It's going to equal e raised to the integral 2x dx. Really just substituting in what my p of x is. A little bit of work to do now then in terms of simplifying this. I want to evaluate that integral of 2x dx. That one's not too bad to evaluate. That's just x squared. What that does for me now then is I have an expression for mu of x. That third bullet of mine, third step in our journey, we now have something to put down for mu of x. And that's going to help me, because as I get into my fourth step now, fourth step is to come up with a y equals, which is going to be our answer. And that's what we're really trying to do in this problem, is come up with the general solution to that differential equation. So we're going to have that y equals function that fits the bill. This y equals step of mine is going to be a formula again. It's kind of a good news, bad news situation. Bad news in the sense that you need to know the formula. But the good news in that if you know the formula, you're just going to put the right pieces of the puzzle in the right place, and you're going to get your answer. So make sure you know the formula for y equals in this type of problem, which is y equals 1 over mu of x integral q of x mu of x dx. That's our formula that's going to get us our y equals. And I mentioned that these are pieces of the puzzle to put in the right place. You can see your mu of x here and here, and you can see your q of x here. So I just have to grab the items that I have lined up and put them into the formula. 1 over e raised to the x squared. integral. My q of x was 10x. That's that same mu of x next, which is my e raised to the x squared, and then dx. So that's the formula for this particular problem with the pieces of the puzzle put in, but you still have a little bit of work to do. Now what I have to do is evaluate that integral. It's kind of like a little mini problem within the problem, is I'm going to sidestep and evaluate that integral. So just what I have underlined in pink, make sure you don't grab the expression in front of the integral. Just what I have underlined in pink, I'm going to go off to the side and work on that. 10x e to the x squared dx. Now I'll evaluate this integral, which if I knew just off the top of my head, I would go ahead and write that answer down and be done, go back over here and keep working. But when it's not so easy, when you don't know it off the top of your head, just use your typical integration techniques. For instance, in this case, I'm thinking u substitution is going to work. So I would let u equal x squared, du dx equals 2x, dx equals du over 2x. Now, the particular steps that you might take in your u substitution could vary a little bit, but we'll both get the same result at the end. This is the way that I line it up, because now I have pieces to put into this puzzle. Integral still 10x still e raised to the x squared I'm going to replace with u, and my dx I replace with this piece, du over 2x. And then I simplify. Here's an x, and here's an x. And also here's a 10, and there's a 2. There'd be a 5 left over. Let me rewrite that and look at it a little bit more cleanly. Looks a little bit cleaner, but also more doable. I can do this integral pretty quickly. Then also with u substitution, don't forget to resubstitute. This equals 5e raised to the x squared power plus c. And that's good scratch work. We got a good answer for that integral, but getting my bearings back, that was all done just for this squiggly underline over here. So let me get back on track over here. I still have the 1 over e to the x squared, but that entire expression underlined in pink, I'm going to replace with 5e to the x squared plus c. That's that same thing. And then really just one more step. We'll just simplify by distributing through the parentheses. E to the x squareds are going to cancel there. I'll just get a 5 plus c times e. Let's make that to the negative x squared. If we bring that denominator up and write it as a negative exponent. So we have a good answer for y equals. That was our goal here in this fourth step of mine. Y equals 5 plus c e raised to the minus x squared power. A little bit of work, but the more work you do, the better you feel about it at the end when you have a nice answer. That's our general solution to this differential equation. Okay, good. Thanks, and I hope that helps.